You are welcome to the majestic tutorial. You are watching the place where top educators deliver simplified lessons across major art and science subjects, a true hub of expert teachers and impactful learning. As you enjoy the class, don't forget to subscribe and share with others. Here I'll be handling the JUPEB 2025 preparatory class, the likely questions now on qualitative analysis. Endeavor to watch my video on the titration questions. As you can see there, I have solved them, and there will also be live stream just a day before the exams. If you are participating, make sure to drop your comment in the comment box there or in the comment section to enable us know how many potential viewers do we have in the house. If there are enough, we'll serve you well. So you can also make this work by sharing this video so that we'll have many persons that will join. So looking at this qualitative analysis, they say you are provided with samples X, Y, and Z. X actually is copper sulfate 6 hydrated copper 2 sulfate, which is blue in appearance. Y is actually zinc dust, and the Z is iron 2 sulfate. That is a ferrous sulfate, the hydrated form of it, which is green. All right, so these are the likely questions that we'll encounter. I'll answer them gradually, putting them in a tabular form and giving you the possible explanations. So we won't be wasting much time. We'll go straight to the solutions. Okay, maybe I will allow the question remain as I solve it alongside also. So for us to move this, I'm gonna put it like this and move, or I might remove it entirely and display it the other side. I think it's better displayed this side. Alright, here we go. So when we have it displayed here, we will now solve here. Just remove this. So I will make a table which will have test, observation, and inference. So the first one, as I zoom in over here, says you are going to dissolve X and Y separately on each 10 ml of distilled water. You just tell them both dissolves, of course, to form X will form a blue solution, YZ will form a light green or yellowish green solution. Okay, then you just say that X or Z or X and Z are all soluble. They are soluble in water. So let's go to the ones that we need careful attention on. And these are that's question 1A. We are to question 1A here. To about 2 cm cubical solution of solution X, add about half spatula of solid Y and allow the mixture to stand for about 5 minutes. Okay, what will happen here is very simple. 2 cm cube of X aqueous plus Y solid plus 5 minutes, depending on what is our observation. This is displacement reaction. Remember, zinc will displace copper from copper to sulfate 6, so there will be brownish particles. Solution C turns what? Solution Z turns or rather solution X turns from blue to colorless. Yes, with reddish brown particles in the solution. Inference: Z, they might tell you that Z is a metal. So if they say Z is metal, you say Z is probably more reactive than the. We have seen it. It is copper. It is, since it's blue, we likely call it copper. So you see that metal Y is, or metal Y has displaced what? Copper to ion from solution X. Or to be on the safer side, you just write displacement reaction occurs. Displacement reaction occurred. Then the next question says, that's the B part of it. It's telling us that to the same thing, you repeat the same thing, but this time around, but with Z, is the same scenario. It will still be displacement because zinc will still displace iron. So solution turns from light green to colorless. Light green to colorless with reddish brown. It is going to be the same report you got here. The only difference is that you will now be talking about no more from blue to reddish brown, but rather the solution will be moving from light green, because ion to ion is green, light green. Okay, so 2 cm cube of Z aqueous plus about 1 gram of X solid plus 5 minutes. So solution Z turns from light green or greenish yellow to colorless. Okay, simply say that X displaces the metal ion in Z. Of course, that's what happened there. Then we move over to question C, which says Ci to the second portion of X, add sodium hydroxide aqueous in drops until in excess. This one is now to officially confirm copper 2 ion, sodium hydroxide and aqueous ammonia. Collectively use them to confirm copper 2 ion. So over here you have second portion of X aqueous plus sodium hydroxide aqueous in drops plus excess, or in drops until in excess. You record your observation is going to be light blue gelatinous precipitate, light blue gelatinous precipitate, which persists in excess of sodium hydroxide. In excess sodium hydroxide, you write Cu2 plus likely or present. Then CII, this is our CI, this is B, and this is A. Remember, it must not be numbered as I'm numbering it exactly here. So the CII, simply we repeat the same process, but this time around, instead of sodium hydroxide, we'll be using aqueous ammonia. So third portion, what I'm using as third portion might be their first portion in the exam. Third portion of X aqueous, because you have been told to dissolve it in water, plus aqueous ammonia in drops plus excess. So what will it be here? It will tell us that there will be formation of still light blue gelatinous precipitate. This time around, which dissolves, it will no more persist, dissolves in excess to form a deep blue solution. Immediately you write copper 2 ion confirmed. You are no more suspecting it. It's no more being suspected. Maybe so far this is the table we have filled with respect to this question. Okay, we have answered question A, B, Ci, and Cii. We now move to D. So we are almost done. The analysis is going to be very easy. So we move to question D. Okay, this is to the second portion of Z, add sodium hydroxide or ammonia. It is either you use sodium hydroxide or you use sodium hydroxide can go or aqueous ammonia, because it's ion 2 ion. You can use either of these to confirm it, unlike copper 2 ion, whereby you must pass through the stage of sodium hydroxide and aqueous ammonia. It is only aqueous ammonia that confirms copper 2 ion, but ion 2 ions, either sodium hydroxide or aqueous ammonia, we all confirm it is the same result, the same observation. So remember, in the exam they will not tell you all, but if they do, no problem, they will choose one. So whichever one they choose to save time, just know that it's the same thing. So we say, maybe let's say second portion there. Okay, I think the other one says fourth portion of X, so probably here is fourth portion, but this is not going to be problem to us. If they say fourth, you say fourth. If they say fifth, but here we are moving to the second portion of Z, aqueous plus ammonia or sodium hydroxide, anyone.
Hello, my name is Okeke Goodness. This is Majestic Tutorials. Keep watching. We got the best for you. Thank you.
In drops plus excess. What is our observation? There will be brown precipitate or reddish brown. No. There is no. It's not true. Please take notes. There will be dark or dirty green. Dirty green. It is gelatinous, meaning it is sticky to the walls of the test tube. Dirty green gelatinous precipitate, which remained insoluble in excess of the reagent. If they use sodium hydroxide, it will still not dissolve in sodium hydroxide. So you now continue. Precipitate turned reddish brown. That's the thing that will confirm the ion 2. Precipitate turned reddish brown on standing. On standing, immediately here you say ion 2 ion likely, and over here if it turns reddish brown on standing, you now write ion 2 ion confirmed, because that's the only ion that will give us green, dirty green precipitate that will later turn reddish brown. The chemistry here is that the ion 2 ion is oxidized to ion 3. Ion 2 ion is green in appearance, while ion 3 is brown or reddish brown, like rust. rust is brown due to the presence of iron 3 ion. All right. So, but when you expose iron 2 to atmosphere, the oxygen will oxidize it to what? To react with the oxygen to give you an iron 3 ion, which is reddish brown by color. So that's why we confirm iron 2, because that's the only thing that can possibly be oxidized to iron 3 on exposure. So to complete question E and F, which is with barium chloride, I'll come over here. My table remains number, test, observation, and then inference. Test, inference. So we go to question E. To the third portion of Z or X, any of them, add barium chloride followed by excess dilute, because two of them are all sulfates. The other one is copper tetrasulfate 6 and insoluble. The other one is iron 2 tetrasulfate 6. This test is targeted towards confirming SO4 tetrasulfate 6 ion, and it requires barium chloride. So immediately you see barium in the exam, which will be followed by HCl. Just know that they are looking for this particular anion, tetraoxosulfate 6 ion. So they might ask you to do it in both, or ask you to do it in sample Z only, but whichever one they say add barium chloride to, this is the exact thing you will write for them. Okay, the test is going to be whatever portion of X, you just say X aqueous plus barium chloride aqueous, we don't have in excess or drops here, plus dilute HCl aqueous. You will just notice white precipitate or white cloudy precipitate, which persists, that is insoluble in excess dilute HCl aqueous. Immediately you add barium chloride to any unknown sample and it gives white precipitate, you simply suspect or infer tetraoxosulfate 6 ion, trioxosulfate 4 ion, or trioxocarbonate 4 ion present or likely. Okay, then immediately it persists in excess, you now write SO42 minus, that's tetraoxosulfate 6, confirmed. This means that both CO32 minus and SO32 minus will dissolve in excess of the acid. So then we go to the last one, or the least question. They say put half spatula of specimen Y in a test tube and add 2 cm of dilute HCl. Okay, this one is displacement reaction all through to liberate hydrogen gas. Your job is to say follow the report the same way. Half spatula of Y solid plus 2 cm cube dilute HCl aqueous. What will happen? Effervescence will occur. Effervescence occurred. Colorless, odorless gas. Colorless, odorless gas evolved, which bond with a pop sound. Which bond with a pop sound. You simply say hydrogen gas displaced from the acid. Hydrogen gas displaced from the HCl. You say X is, or Y rather, please, not X. Y is above hydrogen in the activity series. So these are the possible things we might encounter. Testing with litmus is also possible, even though I didn't see the litmus in the question, but we get prepared. Both solutions are all zinc, not zinc, sorry, copper 2 tetraoxosulfate 6, likely in pentahydrate form, was the sample X, while zinc dust is what we regarded as Y here, but iron 2 tetraoxosulfate 6 pentahydrate, heptahydrate this time around, is our Z. So for hydrolysis, both salts here, which are these and these, they all hydrolyze in water to give an acidic solution because they are all formed like this. If you use litmus paper, it will turn blue litmus paper red, while this one will also turn blue litmus paper red, which means they all give acidic solutions due to hydrolysis. So what if we are required to heat? If the experiment will need us to heat, but I don't think they provided any means of heating, but maybe to prepare you against all odds. If you are to determine the percentage water crystallization here, heating is allowed, whereby you will be told to weigh. You will need a crucible first of all. In determining water crystallization from analysis without titration, you have to give us the weight of the crucible, or say mass of crucible alone. Maybe the mass of crucible alone is 30, or let's say 50 grams. Then you have to find out mass of crucible plus salt, that's the sulfate itself. Maybe they collectively now weighed 65 grams. You now find that's hydrated. This is hydrated, please. Hydrated salt. Then mass of crucible plus anhydrous salt, that is after the color has turned white. If you heat the blue sulfate, it turns white, which means water crystallization is gone. Plus anhydrous salt, you will get definitely something less. Okay, let's take a look at, maybe you got 61 or just 60 grams. So what's the mass of water now? Mass of water is very simple. You just minus 65, minus 60 from 65, which is giving us the mass of water is 5 grams. So you can go on and still use other method to calculate. The same thing is applicable if you are to determine the mass of water in that of sample Z. You follow the same stage process. If you are to now calculate the percentage water of crystallization, and we have gotten mass of water as 5, you now say 5 over 65, not 65, sorry, it's going to be now 5 over 15. Why am I saying 15? Because this 65 is both crucible and the salt. So you minus 50 from 65, which is 15. You get that now? So the mass of anhydrous itself here is 60 minus 50, which will give you 10. So 15 minus 10 is still 5. So I purposely use 65 and 60 because it was added to all of them. They have similar things, so there won't be any much difference. So for you to calculate the percentage of water crystallization here, you just now say mass of water all over hydrated sample, which is 5 over 15 and not 5 over 10 times 100 over 1. Remember, this is assumption. Okay, I think with this we have come to the end of this class of salt analysis. I really thank you so much for watching and for being patient. So remember, you are still on with the Majestic tutorials. We give you the best in the major art and science subjects. both JAMB, WAEC, NECO, JUPEB. Then for university students in the science subjects and the major art subjects, we have experts for that. God bless you. Good luck in your exams. Let's hear your reaction in the comment section. Any complaint or any commendations, we will be glad and open to hear from you.